Hello guys, this is Paul McWhorter with TopTechBoy.com, and I am here with Arduino lesson number 15. And if you've been with us through the first 14 lessons, basically you have learned the fundamentals of working with the Arduino. You've learned about for loops, you've learned about conditionals and if statements, you've learned how to do digital writes, analog writes, you've learned how to do analog reads. You have learned how to interact with the user over the serial port. You've learned how to read input from the serial port. You learned how to read data from sensors. So you've done a lot of this to get the fundamentals out of the way, and so now it is time for us to start doing some super cool stuff. This tutorial is going to be a little bit longer because this is a full-blown project. It's the type of project that if you do and you show your friends, they are going to say, wow, and you are going to be something because there are not many people that can actually do a project this complicated. So what is our objective? Well, we've been playing around with LEDs for some time, and you know how to turn the LED whatever color you want. It's an RGB LED. You know how to do all that sort of stuff. You can just go to town with that LED. You can get input from a potentiometer, or you can get input from the serial monitor and the guy telling what color it wants. But we want to do something really different this time, and what we're going to do is we're going to have a color sensor. And what this color sensor does is it basically reads the color of whatever is put in front of it. So what we are going to want to do is make a project where we can have just any color card that we want. Like I just went and I tried to find every different possible color. And so just not just red, green, and blue, but all the in-between colors, all the colors of the rainbow. And what we want to do is that by whatever color we put in front of the sensor, we want it to turn the LED that color. We want the color of the LED to match the color of the card put in front of it. And so this is really going to take kind of like all the different things that we've learned through the early lessons and bring them together into something that is a really super cool project. Also, this is the type of thing that I want to sort of start transitioning into. I want to start transitioning into really impressive projects. Each time we'll learn something a little bit new, but then we'll be doing a project that will impress your friends. So let's get started on this. Let's kind of just jump right in here. The first thing is you're going to need to hook the circuit up. Well, the circuit is basically the same circuit we've used for the last few lessons, lessons 14 and 13, connecting up an RGB LED. And so you'll use that same circuit as far as the LED side of things go. So you can sort of keep that set up, or you can go in and set this up now. But in addition to this LED, we've got to put the sensor on there, and I'm just going to have to kind of show you a table. It's too hard to try to draw it on here, so I'll show you a table of how to hook the sensor up. First of all, let's talk about which sensor we are using. We are using the VirtuoBotix color sensor, and if you click on this link, you'll be taken to Amazon and you can order that sensor for about 15 bucks, and that's not bad at all. Okay, so you're going to need to get that sensor. Another thing that you're going to need is you're going to need some wires that are not quite like the wires in the SparkFun Inventor Kit that we've been using. It's a little bit different. This sensor is too big to plug into this board, and so you're going to have to hook the wires directly up to it. The wires that you have used so far have been wires like this and this wire. Let me see if I can get it where you can focus on it. Okay. Do you see those wires have pins on both ends, males on both ends? The problem is now to hook to this VirtuoBotix sensor, you need wires that have male on one end and female on the other end. And that's not something that comes in your SparkFun Inventor Kit, but you can order those wires here. They're about 5 bucks. So if you have your Arduino, you can do this project for about 20 bucks. I think it's 15 bucks for the color sensor from VirtuoBotix. It's about 5 bucks for those wires, and I've got links, or you can just go find them anywhere. The thing I do recommend is Don't just go and try to find the cheapest color sensor that you can. This one, I've tried several of them that have not worked. The one that I got from Virtuobotics does work, and you could probably find other ones that work, and I'm just telling you the one that I found that works, and if you use it, you can follow along precisely with what I have been doing. So you need your color sensor, you need your male-female wires, and then you hook up your LED like you did in lessons 13 and 14. And now we have to figure out how to hook the sensor, the Virtuobotics sensor, how to hook it up into, into the circuit. Well, I don't recommend that you try to trace the wires out on this picture, and it's too hard for me to draw. And so if you look on the sensor, each pin is marked. And these are the pins that you need to hook up. There's 1, 2, 3, 4, 5, 6, 7 pins that you have to hook up. I think there's 8 pins on it, but you don't have to hook them all up. You just need to hook up these 7. Pin S0 needs to go to Arduino ground. So you take S0 and you come over and you hook it to Arduino ground. S1 needs to hook up to 5 volts, and so I made a 5-volt rail here, and I hook the 5 volts up to the Arduino, and then I come out from pin S1 and I hook it to 5 volts. And so now I have S0 at ground, S1 at 5 volts. S2, pin S2, it's marked on the sensor. Pin S2 needs to go to pin 7 on the Arduino. Pin S3 on the color sensor needs to go to pin 8 on the Arduino. The out pin on the sensor needs to go to pin 4 on the Arduino. VCC on the sensor needs to go to 5 volts on the Arduino. Again, I come over here to my 5-volt rail that I made, hook it up there, and then the ground on here needs to go to ground. And so you're going to have 2 of the pins hooked to ground, 2 of the pins hooked to 5 volts, and pins S2, S3, and 4, S2, S3, and out hooked to 7, 8, and 4 on the Arduino. Take a little time and hook that up. Guys, check your work, because we're going to be getting into some hairy programming, into some really intense stuff here, and you cannot afford to have a mistake on your circuit. So really make sure that you hook this up before you go on forward in coding with me. Make sure that you have that hooked up right, because you'll drive yourself crazy if you don't have the circuit hooked up right. It's simple enough, but just double check what you're doing. Okay. And then when you have it hooked up, it should look something like this. These LEDs will come on. Those sort of illuminate the card that you put in front of it, and so that's good. And then what the goal is to turn this LED the color you want. Again, I like to put a ping pong ball on top of the LED and make a little lamp. Makes it a little bit easier to see. Okay, now how does this sensor work? Well, it reads 3 different numbers. When you put a card in front of it, whatever card you're using or whatever color shows up in front of it, it's usually never a pure red, a pure green, or a pure blue. It's a mixture of red and green and blue. And so if you want to read it, what you need to do is you need to read the red component, you need to read the green component, and you need to read the blue component. And if you can read the red and the green and the blue component, then you can make it turn whatever color, whatever specific color that you want, because you know those components. You know your red, you know your green, and you know your blue. Okay, so how is it that we make those measurements? Well, what we need to do is we need to tell the sensor what color we're trying to read. If you want to read red, what you need to do is you need to set pin S2 low, and you need to set pin S3 low. Okay, so you put pin S2 low and S3 low, and you will read red. If you want to read blue, you need to put pin S2 low and pin S3 high. If you want to read green, you need to put pin S2 high, and you need to put pin S3 high. So what you do here is basically you do digital writes to those pins S2 and 3. You write low, 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 high, high, high to read those different colors. You know how to do digital writes, and so you do digital writes to tell it which one you actually want to, which color you actually want to write. Now, how do we go in and do the measurement? Well, the way the measurement is done is it's done from the pin on the sensor called out. And remember, we were going to hook that out pin to pin 4. And when you go in to Arduino and start programming it, you got to name that something. We're going to name it, if you follow along with me, we're going to name it out pin. And the way you actually do a measurement is you do something that we haven't really talked about in Arduino before. You measure a pulse width. And there is a command in Arduino called pulse in. To do a pulse in measurement, you have to tell it what pin you want to make the measurement at. Well, we're going to make the measurement at out pin, which is connected to pin 4 on the Arduino, which is the output on the sensor. So the output on the sensor goes to pin 4, and then we name that in our program out pin. So we go out to that out pin, and we want to read a low pulse, meaning that we want to read a low pulse. And if we do this command of pulse width is equal to pulse in, read the pulse width at output pin, and looking for a low pulse, what that will return and put in your variable pulse width, it'll put the width of the pulse that it sees on that pin in microseconds. Okay? And the way the sensor works is it outputs a pulse width to that out pin that is proportional to how strong the color is that you're reading. So let's say that we're going to read red. We would set S2 low, we would set S3 low. That's with digital writes, and that's telling Arduino, hey Arduino, I want to read red. Okay, by setting that low and that low, that is saying that we want to read red. And then that is sent to the sensor, and then we do this pulse width measurement using our pulse in command, looking for a low pulse, and then it returns to us how long of a pulse it sees there. And what the sensor does is, the way the sensor works is, the longer the pulse it gives you, the weaker that color is that you're measuring. The shorter that pulse is, the stronger that color is that you're looking for. And so if we got a really short pulse width back in looking at red, that would mean it's got a really strong red component. If we got a really, really long pulse width back, a very large number, that would mean that the red component is very small. So if I took a blue card, this blue card doesn't have hardly any red component to it. If I put that in front of the sensor, it would give me a long, and I read red on a blue card, it would give me a very large number back because there's not much red in blue. And so the thing, I say it several times just so you understand it, the larger the number you get back into pulse width, that means the weaker that color is that you're trying to read. So what do? Well, we put low, low to read red. We do low, low, and then come in and read red. We do low, high, come in and read blue, and then we do high, high to come in and read green. And then we've got sort of these three numbers that are sort of telling us red and green and blue. The problem is they're not kind of really very much related to what we think in terms of red and green and blue. It's a number that could be anywhere between 0 and 102,400. And so if it read somewhere near 0, that means whatever color we're reading is very strong. If it read something up around 100,000, it means that color that we're reading is a very, very weak color. So we gotta play around with this to get this into something that would make sense. First of all, we got to read it into a variable, and normally you would read this into just a normal int. The problem with an int variable, the ints can only be between plus and minus 32,768. That's the biggest int number that you can have, is plus or minus 32,768. And since this pulse width might go all the way up to 102,000, an int isn't going to hold it. I don't want to make a float, though. There's a special type of int that we haven't talked about yet, and it is the unsigned int. Unsigned, let me highlight that. Unsigned space int. Declare pulse width to be an unsigned int. So you would go unsigned int space pulse width, And that way pulse width is a special type of integer that could hold a number up to 4 million and something, and so that would be plenty big to hold it. So one kind of key thing right off the bat, you got to be careful declaring your variables on this project, and you're going to need to declare this pulse width, or whatever number you're reading those color numbers into. It's got to be an unsigned int to make sure that it can hold it. All right. Now, the other thing that you have to see is that this is a great big huge number, and really if you're doing RGB, like if you go in and play with Photoshop and you have a red component and a green component and a blue component of a color, typically those numbers are presented as numbers between 0 and 255. Okay, so pure red on Photoshop would be the number 255 for the red, the green component would be 0, and the blue component would be 0. All right, pure green on Photoshop would be red component 0, green component 255, and blue component 0. And so the numbers that you typically deal with when you're talking about RGB, red, green, blue colors, are numbers between 0 and 255. So this number between 0 and 102, 400, we need to scale that down to a number between 0 and 255. Well, I played around with it. It just so happens that, and I'm going to have 3 different colors, 3 different variables. I'm going to have red color strength, I'm going to have green, or R color strength for red, G color strength for green, and B color strength for blue. And so those are going to be 3 variables that we're going to use to hold the red component of the color, the green component of the color, and the blue component of the color. Well, if we take this number that we read here in this pulse width measurement that's between 0 and 102,400, and if we divide that number by 400, we get a number between 0 and 256, which is almost exactly what we want. So if we divide this number that we get from this pulse width measurement and we divide it by 400 and we subtract 1, then we get a number between 0 and 255. So what are we going to do? We're kind of going to come up here and we're going to set S2 low, S3 low, and we're going to do a pulse width measurement. There we have the sort of raw red component of the measurement, and then we come down and take that raw red, we divide it by 400, subtract 1, and that's what we call R color strength. We repeat that for the blue and we repeat that for the green, and so I would have then an R color strength, a G color strength, and a B color strength for those 3 components of the color, an R, a G, and the B. The good news is all 3 of those numbers are going to be between 0 and 255. The problem is that it's going to kind of be backwards, because this sensor is reporting a really big number for a weak color and a really small number for a strong color. So we need to sort of flip that around where, like normal people think, the bigger the number, the stronger the color. And the way we could do that is to say, like, R color strength is equal to 255 minus R color strength, and that just flips it around to where all of a sudden a strong color is a big number. And you would need to do that for G color strength. G color strength is going to be 255 minus G color strength. B color strength is going to be 255 minus B color strength. I'm going to go through the code with you, but we've got to kind of think about what we're doing, okay? We're telling it what color we're going to read. We're going to read that color, and then we've got to sort of manipulate it, do a little math to get a good R, G, and B color. Okay, now once we have those 3 numbers between 0 and 255 for red, 0 and 255 for green, and 0 and 255 for blue, what can we do? We can write them to the LED, and if we write them to the LED, then that LED should change to whatever color card that we put in front of it. Easy to say, a little bit harder to do, but we're going to go through this step by step. If you follow along, you'll be able to do it. I think at this point that you should have your circuit hooked up and working. I mean, your circuit should be hooked up and turned on. So now we're going to have to kind of do the code, and we're going to go through it with you and do the code. Okay. There's several things that we got to think about. We got to remember that we still have to make this LED works. So we're still going to have to declare our variables to the LED. And so let's just go back and do this. You should have some of this done from the earlier lessons, but if you don't, I'm just going to kind of go through the whole thing here. This is a longer lesson. You might want to take it in two or three parts, but I want to have it all together in one lesson, and then you can sort of just go through it on your own pace. But this lesson is going to be a little bit more intense than some of them. Well, we're going to need the red pin on the LED, like in lesson 13 and like lesson 14, and let's call that red pin. And according to that schematic that I showed you earlier, remember we're connecting the red pin to pin 11. Okay, so this is the red pin. We also had a green pin. Okay, green pin on that schematic was hooked to 10. This is our green pin. Okay, we also have a blue pin. Blue pin is hooked to pin 6 on the Arduino. So we come in and that is blue pin. Okay, so that is what we need there. Remember also we have the color sensor that we have to worry about. Okay, so the color sensor we talked about on that table, that pin S2 you were supposed to hook to pin what? 7. Color sensor pin S2 to Arduino pin 7. We also had pin what? S3, and that was going to be hooked to pin 8 on the Arduino. Color sensor pin S3 to Arduino pin 8. Okay. Then also remember we had that out pin. The out pin on the sensor was going to go to pin 4 on the Arduino. You can kind of hook this up differently, but you got to make sure that how your circuit is hooked up matches how you declare things here. And so this is, whoa, did not mean to do that. So this is set, or this was color sensor, the pin's called out on there, to Arduino pin 4. Okay, I think those are the pins that we're going to need. All right, you have to make sure you hook those to 5 volts and you hook the things up, but you don't have to program that in, but just make sure when you hook the circuit up you have all the wires hooked up as I indicated on that some schematic. Okay, when we get to our void setup, what do we do in a void setup? We do the things that we want to do one time. I am sure that we're going to need that serial port before this thing is over, so we're going to do a serial begin, and we've got to spell things right. Serial.begin 9600. Boom, like that. Okay, that turns on the serial port. Turn on the serial port. Okay, let's go and do our pin modes now. First of all, we have our LED pins, so we're going to have to say pin mode. And what do we have? Red pin, and that is an output because we're going to write to it. We're going to have pin mode, and we are going to have green pin, and that's going to be an output. We're going to have pin mode, and we're going to have blue pin. That's going to be an output. All right, so we've got those 3 pin modes done. Let's go do the pin modes on the sensor now. So we're going to have pin mode, and we're going to have pin S2. It's going to be an output. Okay, pin mode, we're going to have S3. It's going to be an output. Remember, those are the pins. S2 and S3 are the pins that we write to on the sensor telling it what color we want to measure. So we got to make sure that that is an output. Now, pin mode out pin, that's the number that's the output of the sensor. That's the number that's the sensor, that's the pin that we read from. So to the Arduino, that would be an input. So we're going to read from that pin on the Arduino. Okay. So I've got my LED pin set up. I have got my sensor pin set up. I think our void setup, is in pretty good shape. So now we need to come into our void loop. Okay. Now, what are we going to do in our void loop? We need to go and we need to read our colors. So how do we read our colors? Well, we got to start by telling it what we want to read. So let's start by reading the red component of the color. I want to read the red component, okay? How do we read the red component? S2 and S3 should be set low. How do I know that? Because I told you that over here. And if you go to toptechboy.com, Arduino tutorial number 15, you can see that if you want to read red, S2 and S3 should be low. So I do a digital write of S2 and S3 low. How do I do that? You should know that by now. Digital write, and we're going to write what? S2, and we are going to write S2 low. Okay, then digital write, we need to make S3 low. That's telling the Arduino we are fixing to read red. Okay, how do we read it? Well, oops, we forgot to declare a variable up here that we're going to need pulse width. Remember pulse width? What was that going to be? That was going to be that big number, so we need that to be an unsigned int, and that is pulse width. So we're going to read a big number into that. Pulse width is going to be an unsigned int, and it can take a big number. So now that we've declared that, we forgot to do that up front, we can make the measurement. We make the measurement by saying pulse width. What do we want to measure? We want to measure the length of the pulse at the out pin. How do we do that? It is that command I told you about earlier, pulse in. That will measure the pulse width. We got to tell it where to measure. We measure at the out pin. And what we look for a low pulse because that's the way this sensor works. Okay, so how does this work? You could call this whatever you wanted to here. Just make sure that you declare that up here. But the pulse width, how long in microseconds that pulse that's being put out by the sensor, I get that by doing a pulse in measurement where at the out pin, what is the out pin? The out pin is pin 4. That's what's connected to over here, the out pin on the sensor. So I just made my first measurement. It's pulse in on out pin and look for a low pulse. Okay. Now, that is going to be our R color. And we better declare some variables up here for our 3 colors. We didn't do that. We should have done that. So we need an int for our R color strength. I'm not going to assign anything to it because I'll read that. But that R color strength needs to be declared up here. We're going to have an int for G color strength. Okay, and then we have an int for the blue color strength. Okay, so for every card that I put in front of the sensor, I want to read 3 components. I want to read the strength of the red component, the strength of the green component, and the strength of the blue component. Well, those 3 variables are going to be R color strength, G color strength, and B color strength. And I should have remembered to declare those up front, but at least before I got too far in it, I remembered that I need to do that. So I've declared pulse width. So now I read with S2 and S3 low, and so basically that's reading red. So this is going to be R color strength, and that's going to be equal to what? It's going to be equal to pulse width divided by 400 and then minus 1. and we talked about that will take those numbers from 0 to 102,000 whatever down to a number between 0 and 255, which is a nice number when you're talking about how strong is red. You would want that to sort of be a number between 0 and 255. So we've scaled that crazy number down to something that makes a little bit more sense when we're talking about colors, okay? But you remember how these colors were backwards, that a big number meant a weak color and a small number meant a strong color. So what we need to do is we need to flip that around. So our color strength is going to be equal to, and what are we going to say? It's 255 minus our color strength. Okay, so we've taken it and we've flipped it around to where a big number means a strong color now. So all of a sudden now, I think that I have a pretty darn good number for red. I don't want to retype this whole thing in for green, and so what I'm going to do is I'm just going to copy this. I'm going to come down here and paste it, and when you do this, you better be so careful to make all the changes you need. So now let's read the green component of the color. Well, if we want to read green, we need to come back and say, okay, how do we read green? Well, to read green, we need both of them high, S2 and S3 high. That's going to be kind of fun. So S2 and S3 should be set high. High. So we're going to set S3 high. We're going to hit S2 high, and we're going to set S3 high. Now, pulse width now is going to be, again, we're just using this as sort of a placeholder. So pulse width is that pulse in, out pin low, only this time we're reading green. And so this time, green G color strength is going to be pulse width divided by 400 minus 1. And then to get it going the right direction, G color strength is 255 minus G color strength. Pretty neat. I think I have the red component of the color, and I think I have the green component of the color. Now we need to do the blue component of the color, and I love to copy and paste, but I do it very carefully. It makes it easier to not have to do all these things separately. So now what we're going to do is on this one, we're going to say, let's read the blue component of the color. And how do we do blue? Let's come and look over here. To do blue, we go 2 is low and 3 is high to do blue. Low, high to do blue. And so we need to do low on 2, high on 3. And so S2 and S3 should be set low and high respectively. Something like that. Okay. Now, again, pulse width is just sort of a placeholder to go out and get the raw number. But now we're doing blue. And so this would be B color strength is equal to pulse width divided by 400 minus 1. And B color strength, to get it switched in the right order, where a big number means a strong color, B color strength. I think now I have the red component, the green component, and the blue component. Before I get too fancy, I want to run this thing because there's no telling how many mistakes I've made. You're probably out there screaming at me the mistakes I made. But let's print out those three colors now. So I'm going to do serial.print, and I'm going to print R color string. Okay. And I want it on the same line. I want a comma, so I'm going to say serial.print, and then I'm going to print a comma. Okay. Now I'm going to do serial.print, and now G color strength. Okay. And now I'm going to do serial.print. I'm going to print another comma. So I get all the red, the green, and the blue all on one line. And so it will scroll by and make sense. Now I'm going to do serial.print LN, because this time I want to go to the new line, and I want to print B color B color strength. Okay, and now I'm going to print a blank line just to make it easier to read. Print line, and we're going to do the double quotes there to make it easier to read. Okay, so now I probably made some mistakes in here, but we'll debug it, and then what we should be able to do is that when we put a card in front of the sensor, it's not going to be perfect, but if I put a green card on there, the G component should be the largest number. If I put red, the red should be the largest. If I put blue, the blue should be the largest. Green should be the largest. So the red, the green, and the blue, I could at least see that component should be the largest. And then we're going to have to start playing with it to get it to work really in a fancy, fun way. But for now, it's kind of a starting point. So let's see, is it going to run? That's a lot of typing. I hope that there's a very good chance, I think probably, that somewhere in there I made a mistake. But let's just run it. Ooh, right off the bat. What does that not like? R color strength. I probably misspelled something. Ah, no, I forgot my colon after that. Why didn't somebody yell at me? Which means I copied and pasted, which I propagated my error. Okay, forgot my semicolon. So now let's try it. Ooh, R color strength was not declared in the scope. So did I misspell it? R-C-O-L-O-R-S Ringatha. R color strength. R color strength. I'm sure you guys see it, but I don't see it. I do not see it. R-C-O-L-O-R-S-T-R-E-N. N. We're missing an N. Boom. I am severely dyslexic, so it is extremely difficult for me to find little glitches like that. Ooh. And that is going to be the same mistake. We are leaving our N's out of these things. We can go through and fix those. Okay, let's see if that fixed them. I left an N out. And this is expected. Ah, forgot my colon on that one. Hopefully some of these guys, hopefully some of these you found as I was typing them in and you got it right. Okay. And B color strength 0.printline. They've got my token. Why does it think I don't have a token? Ah, I accidentally have an extra open parentheses. Okay, so just one open parentheses. So this is debugging. Usually when you have a mistake, it takes you to the line where the mistake is. It looks so right, but if it tells you it's wrong, it's wrong. Just don't get into this thing that you think it's broken. You're the one broken. You made a mistake. Just find it. Find the mistake. Sometimes get somebody else. If you really get stuck, get someone else to come in and look at it. But it's always that you made a mistake, and it's usually kind of shows you which line it's on. So let's see now. Ah, it's going to download. We just made 8 or 9 mistakes, which isn't too bad. Didn't quite take it all the way down there. Let's see what happens. Let's see if we can get it. All right, I think it went that time. So now, okay, so we're printing values. Oh boy, that's going way too fast. Let's slow it down a little bit. I need to put a delay in here so it doesn't go quite so fast so we can kind of see the colors. So after we do one, let's say delay, and delay is in what? It's in milliseconds, so 1/10 of a second would be 1/10 of 1,000 milliseconds. Let's delay 100. Now let's come in and look at it. Okay, so let me take a look. Okay, so remember it's RGB, red, green, blue. So now it's just pointing to no nowhere land, and so you're just getting random numbers. But if I put a green card, look at this. The green number is turning out to be the largest number. I don't think I downloaded that darn thing because it's still going pretty fast. Let me slow this down. Okay, now let's look. Remember, it is red, green, blue. So if I put red, look at that. The first one, red, is the largest number. It's 244, 223, 233. So red is the largest number. So that's good. When it looks at red, it sees red as the largest number. Let's look at green. When it looks at green, okay, 235. That's the largest number, 236. It's seeing mainly green. Okay, and now if I put blue on there, look at that. 248 is the largest number. So when I have the red, the green, and the blue, if I were just sorting red, green, and blue, I could see which number is the biggest, and I could say you got a red one, you got a green one, or you got a blue one. And so that's pretty cool. Okay. Let's try something here. Let's try to now write those values to the LED. The problem is, I'm not going to go through it because I know that it doesn't work just right off the bat. The problem is that if we look at these numbers, while you can see red is the biggest number, the problem is these numbers are too close together. And if I fed those numbers back into writing the R, the G, and the B pins on the LED, it's not going to work. And the reason is that it would all look white because it's like they're too close together. If you want it to be red, it's like the red's really got to be big. So we got to figure out how to amplify it a little bit. Let's do one thing. Let's just kind of cheat a little bit, and then let's do some if statements in here. If if our color strength is the biggest. Well, for our color strength to be the biggest, what would it need to be? It would need to be bigger than blue, and it would need to be bigger than green. And so let's say if our color strength is greater than B color strength. And how do we do an and? Double and, shift 7, double and our color strength is greater than G color strength. I'm going to start copying here so I can just go to town. Greater than, what is it? Also greater than green. So if red is greater than blue and red is greater than green, what would we want to do here? Well, we got to open our clause, and we would want to, let's just do digital writes because they're easy. Digital write red pen high. You would want to digital write blue pen low. Why? Because it's red. It's not blue. Digital write green pen low. Okay, so what does that do? That's saying if red is the strongest color, turn the LED red. So now let's come in and let's take this and let's do the other two real quick. That in this case, Control V, what we would want is if green is the biggest, then green would be bigger than blue, and green would be bigger than red. And in that case, what do? We want red to be low. Why? Because we want to turn it green. So we would have this high. Okay. Let's do the third one. Control V. And what we're going to do is, in this case, it's for if blue is the biggest, we want to turn it so if blue is bigger than red, and if blue is bigger than green, then blue is the highest, and so we would want to write blue high, and we would want to write red low. Is this going to work? I am super excited about this. Remember, we're kind of cheating now. We're cheating because it's just like, oh, why did it not like that? Digital right, green pen. Ah, forgot my closing. Okay, you see it told me it was on this line, and then I saw that I forgot that closing. I hope, oops, and it's going to be on all three of those because we copied and pasted. You live by copying and pasting, and you die by copying and pasting. And why does it? Ooh, we didn't close our clauses. I told you always have to close the clause. So that closes, this closes that clause. We did not close any of these if statement clauses. Why didn't somebody yell at me about that? And then here. Okay. So this if statement starts here, ends here. This if statement starts here, ends here. This if statement starts here and ends here. Now let's try it. Man, I made a bunch of mistakes. I got too excited, went too fast. Okay. So let's see. I'm going to put the blue card in front of there, and it turns blue. I'm going to put the red card in front of there, and it turns red. And I'm going to put the green card in front of there, and it turns green. Okay, that's like, don't get too excited though, because, I mean, that's just showing you that you can do the three colors, but we cheated because we programmed it knowing that there was only going to be red, green, and blue. What if I want any color in the world to come up? You see it can't do purple because we kind of hardwired it in there. But I showed you that because it's going to get kind of tedious, and what we want to do is we want to have a little bit of a success before we move on. But the truth is that most colors, in fact no colors, are all red or all green or all blue. You've got to read the red component and write it, and you've got to read the blue component and write it, and then you've got to read the green component and write it. Okay, so I'm going to take these write statements out that we just did that just to have a little fun, okay, to have a little success here. Okay, I'm going to take those out, and now I'm going to download the code again. And now we're going to look at this. I am still having trouble downloading my programs. Okay, so now again, if I put red in front of it, look, the red is the biggest number, but just barely. And if I put the blue in front of it, RGB, the third number, blue, is the largest number, but just barely. And if I put the green in front of it, the green, the middle one, is the largest number, but just barely. So if I just fed those three numbers, RGB, into the LED, it's going to look white because there's not enough difference. You got to have big differences. So we have to take these three numbers and we got to amplify them. We got to like exaggerate them. And there are all kinds of different ways that you could think about exaggerating them. But what I want to do is I want to do it this way. Whatever number is the biggest, I want to make it 255. It's just like if red is dominant, man, bam, I'm going to turn the red to 255. So whatever number is the biggest, if red is the biggest, I'm going to set red to 255. If green is the biggest, I'm going to set green to 255. And if blue is the biggest, I'm going to set blue to 255. So when it makes a measurement, whichever is the biggest one, bam, I'm going to take it right to 255. Similarly, whatever is the smallest number, I want to get rid of it. So whichever is the smallest number, I'm going to set to 0. So the biggest number, I'm going to set to 255, whatever the biggest color is. Okay. The smallest number, whichever one is the smallest, I'm going to set it to 0. And then whichever one is in the middle, I'm going to set it halfway. I'm going to take whatever the number was that it was reading, I'm going to divide by 2. And so that way it's going to amplify the colors, that if it's mainly red, it's going to make it mainly red, and it's going to get rid of the little tag along not so big color. So let's imagine that if I put red here And let me stop this scrolling. And it's reading 244 for red, which is good, 220 and 228. What I want to do is I want to make 244, take it to 255, make it full blast. What's the smallest one? Red, green is the smallest one, so I want to take this green and I want to set it to 0 because, you know, I'm going to get rid of the green. And then this blue, it's seeing a little blue in here, but I'm going to take this blue number, red, green, blue, and I'm going to divide by 2. Okay, so in order to do that, what we got to do is, let me move this out of the way because I want to do this. What you got to think is, I've got 3 colors. I have R, G, B. Okay, and we got to think about what is the biggest, the middle, and the smallest. Well, what are the possibilities? It could be RGB. If red's the biggest, green is the second biggest, and blue is the smallest, I would want to take red to 255. I would want to take green to whatever green was divided by 2. And I would want to take blue to 0. Okay. What's the other possibility? It could be R, but it could be BG. Biggest is R, smallest is green, and blue in the middle. What else could it be? Well, maybe green is the biggest. If green is the biggest, then it could be red, blue, or it could be green, blue, red. What else could it be? Blue could be the biggest, and then it could be red, green, or it could be blue, green, red. So there are 1, 2, 3, 4, 5, 6 possibilities. And then in all of these 6 possibilities, whichever is the biggest, I want to make 255. Whichever is in the middle, you just take it and divide by 2. And whatever is the smallest, you make it 0. This is just a crazy thing. This is just a crazy idea. But it just might work. Okay? So, let's come in and let's write some if statements. So, let's think about, we want to go through these. And we don't want to be stupid and make a bunch of mistakes like I did last time. All right, so what would be if R color red, let's do red is big, let's check for R color, R color stringtha is greater than G color stringtha, and G color stringtha is greater than B color stringtha. That is this first case. R is greater than green and green is greater than blue. That's the first case. In that case, what would you want to do? Well, R is the biggest, so I would want R color stringtha to be equal to 255. What's the smallest one? Or what's the middle one? G color strength. G color stringtha. I want that to be equal to G color stringtha divided by 2. Okay? And then what do we want to do with the small one? B color stringtha. We want that to be equal to 0. So I'm amplifying the red and I'm killing the blue and I'm letting you have a little green in there so we can get these in between colors. It's crazy. It's crazy. I've tried lots of different things. It's crazy. Now let's consider the other possibility. Okay. And remember, we can really kill ourselves, but now let's do the second one. For the second one, R is bigger than B and B is greater than G. R is bigger than B, B is bigger than G. For that case, we want R to still be 255, but in this case what we want is the blue is in the middle, so the blue would be the one that is divided by 2, and then the green is the small one, so we would want green set to 0. Boom, that went fast. We're going to be done in no time. Okay, what's the next one? The next one is when green is the biggest and red is in the middle. So we have green the biggest, red in the middle, red in the middle, and then blue. Okay, in that case, blue is small, so we want it to be 0. Okay, we want green to be the biggest, and so we want green to be 255. And then it is the darned red this time that is in the middle and gets divided by 2. Make sure you change it on both sides. Red color strength is red color strength divided by 2 because red is in the middle. I'm going to copy that one because it's going to be a little closer to what we want probably. Okay, we are already down to the fourth one. And the fourth one again is green is the biggest. Ooh, I messed up there. Color. Let me check these. Those look pretty good. I probably made another mistake in here. Okay, but here what we want is we're on the fourth one, blue in the middle. So green bigger than blue. So we're going to have blue color strength, and then blue color strength is greater than red, and so red is the small one. If red is the small one, we want red set to 0. We want blue is in the middle, so blue is equal to blue divided by 2, and green is going to be 255. Okay, so now we are down to this one. Blue's the biggest, red's in the middle, and green's small. So what do we do there? Okay, well, what's going to be the big one there? Blue is the big one. Which one is in the middle? Red is in the middle. Doggone it, I should have fixed that. R is in the middle. Okay, R is in the middle. And then what's the little one? Little one's green. If the little one is green, we want green to be 0. What's in the middle? Red. We divide by 2. And what's the big one? The big one is blue. Okay, now let's copy that. And this should be the last one. Ooh, not good. This should be the last one. So now we have blue is the big one. So we have blue is the big one. What's in the middle? G. So we make this G, and then we make this G, and G is bigger than what is the little one? Is R. R is little, so we want R color to be 0. What's in the middle? G. G is in the middle. Okay, and then what is the big E? The big E is blue. All right, this is so exciting. This is so exciting. What is the chance that this is actually going to work? Slim to none. That I didn't make a mistake somewhere in here. Okay, but we're going to be brave. We're going to take our medicine and see. Ooh, ooh. Boom. It is going to, at least we didn't get an error. An error might take a time or two to get it down there. Okay. All right, it took. So now let's see. Forgot something. Okay, now I've got 3 good numbers for red color strength, green color strength, and blue color strength. What did I forget to do? I forgot to write them to the LED. So now I need to do analog writes because we're doing those in-between colors. Analog write. Where are we writing? Red pen. What would we write to red pen? R color strength. Okay. And I think that I will copy this. And then I will copy it. And then what we're going to do is write green pen is going to be G color strength. And then blue pen is going to be blue color strength. Okay, so now these numbers that I'm reading from the color sensor and I'm manipulating, now I'm going to go and I'm going to write them out to the RGB LED. And let's see if this sucker is going to work. Okay, This is a long video. This is going to be about an hour. As these things get more complicated, you might want to break these videos up into two. Okay, it has downloaded and we are ready to try it with all of these different colors. We don't expect it to be perfect the first time, but hopefully we'll be close enough to just tweak it. What we want to do is just notice as we go through, is there too much of one color or not enough of another one? So let's start by looking at red, and when I look at red, what I'm seeing is just a little bit too much blue in that, okay? Let's see if we can see that. Yeah, I've got a lot of blue in my red. If I look at orange, I'm seeing a little bit too much green in my orange. If I look at blue, blue looks good. Purple looks purple. Pink looks pink. Orange looks a little too green. Green looks green. This green, a little bit too much blue in it. Yellow, a little bit too much green. Purple's good. Blue is good. Okay, what I saw was I saw quite a bit too much blue. So I'm going to come in addition to everything else we've done. In addition to everything else we've done, I'm going to put B, color strength is equal to B, color strength times 0.5. And that's just because in all of those I was just seeing too much blue. It's almost like we're getting a blue cast on this thing. So I'm going to turn that down. Now let's go, and also I saw a little too much green but not a lot. So G color strength is equal to G color strength. It wasn't quite as bad. I'm going to say times 0.75. Basically, it could be my particular LED, it could be my particular sensor, but my red is a little bit weaker than what I want, and I'm getting kind of like a lot of blue, and I'm getting a little bit too much green, and so I'm just doing this final tweak, and I am hoping that we're going to nail it this time. So let's get my cards here. Oh, gotta put semicolons, It is late in the day today. It's been a long day. So let's come in, let's download it. It's looking happy. It is looking happy. All right. So here we go. Let's try red. Okay. Red is looking very red this time. That looks good. I am happy with that. Orange looks orange. Blue looks blue. Purple looks purple. Pink looks pink. Orange looks orange. These are really dead on. Lime green is lime green. This is kind of a pale yellow, comes in as yellow. Purple, perfect. Blue, perfect. And green is coming in with a very nice deep green. Boom! This thing is working. So what we can do is we can just take something that we find, we can put in front of it, and it matches the color. I'm just picking up stuff here. We put it in front of it, it's matching the color. Let's see, I've got a little, I don't know if it can read something this small, but let's say I got a little red tag here. I can put that on there and boom, it's turning red. So we have got a color matcher. Whatever you put in front of that color sensor, it matches it on the LDD. This has been a long project. This has been a good project, but I hope you have enjoyed it. Paul McWhorter, TopTechBoy.com, signing off on Arduino lesson number 15. Hopefully you'll check in with us very shortly to do Arduino lesson number 16. Talk to you guys later.